I don't remember. Good morning, guys. I'm going to record all of the review. So we're going to work it from start with number one. Numbers 1 through 3, you're supposed to use substitution. So the first thing I would do is subtract 3y from both sides of the equation, and then plug negative 3y into the second equation. But you need to be careful because of the negative sign. So negative of a negative would be positive 3y minus 18 plus 2y is equal to 7. 3y plus 2y is equal to 5y minus 18 is equal to 7. So we get 5y is equal to 25, so y is equal to 5. We need to plug y back into one of the original equations. I'll just plug it in the top equation and get x is equal to 3. So the ordered pair is 3 and 5. It is consistent and independent. Problem number 2. You're supposed to work the same way, so I would probably add y to both sides to get y plus 2. And then I'm going to take all of this and plug it in for x. So I have 2 times y plus 2 minus 2y is equal to 10. So I have 2y plus 4 minus 2y is equal to 10. So I come up with 4 is equal to 10, which is not true. So we know it is inconsistent and no solution. Everybody okay with that one? In the next equation, we're supposed to do this with substitution as well. I would probably subtract 1/3 x from both sides of the equation, and then take all of this and plug it in the top equation. So I have 2x plus 6 times negative 1/3 x plus 1 is equal to 6. So I have 2x plus, that would give me negative 2x plus 6 is equal to 6. So I get 6 is equal to 6. So this is an infinite number of points on the line y, such that y is equal to, we'll say negative 1/3 x plus 1. It is consistent and dependent. Alright, problems numbers 4 through 7 are supposed to be solved using elimination. Problem number 4 is pretty much set up already for elimination. You would just add the second equation to the first equation and you would eliminate x. So when we add these two together, we get negative y is equal to negative 2. So y is equal to 2. To find x, I would probably put 2 back into the second equation and get x minus 6 is equal to negative 1, so x is equal to 5. So I have 5 and 2 as the solution. It is consistent and independent. Everybody okay with that one? On to number 5, we need to decide what we're going to eliminate. So are we going to eliminate x or y? If we eliminate x, we'd have to multiply the top equation by negative 3. So if we multiply the top equation by negative 3, we get negative 6x plus 9y is equal to negative 18. And we have 6x minus 9y is equal to 9. When we add these two equations together, you see where we eliminate both x and y, so we come up with 0 is equal to negative 9, which is not true. So we know that they are parallel, inconsistent, and the empty set, or no solution. Everybody okay with number 5? number 6, we need to rearrange the order of this. So we have 2x plus 9y is equal to negative 12, and 4x plus 3y is equal to 6. So what do we want to eliminate, x or y? All right, so we'll multiply the top equation by negative 2 and get negative 4x minus 18y is equal to 24. When we add these together, we get negative 15y is equal to 30. Correct me if I'm wrong, y'all, and get negative 2 for y. So if we have negative 2 for y, what do we want to plug it in? I'll plug it in the second equation, and we get 3 times negative 2 is equal to 6. So we get 4x is equal to 12. So x is equal to 3. So I have 3 and negative 2. It is consistent and independent. Everybody okay with that one? All right. On number 7, do we want to eliminate x or y? Probably the easiest thing to eliminate would be what? Y. We multiply the top equation by 3, we get 15x minus 6y is equal to, what is that? Negative 57. If we multiply this equation by 2, we get 4x plus 6y is equal to 0. So when we add these two equations together, we'll eliminate y. So we have 19x is equal to negative 57. So x is equal to negative 3. So if x is equal to negative 3, we have 5 times negative 3 minus 2y is equal to negative 19. And negative 15 minus 2y is equal to negative 19. So negative 2y is equal to, what is that, negative 4. So y is equal to 2. Do I have that correct? So I have negative 3 and 2. It is consistent and independent. All right, so on the next one, number 8, we're supposed to graph these. So remember that the absolute value of inequality is x plus 1 is less than or equal to 3, and x plus 1 is greater than or equal to negative 3. So I have x is less than or equal to 2, and x is greater than or equal to negative 4. And I need to rearrange the order of the other equation. So we'll do this in red. So we have 3y is greater than negative x plus 6. Divide everything by 3. We get y is greater than negative 1/3 x plus 2. So what kind of equations or what kind of lines are x is equal to some number? X is equal to some number is a vertical line. So we'll have a vertical line on x is equal to 2. It is solid. We'll have a vertical line on x is equal to negative 4. It is also solid. We plug in some numbers in our red equation. We plug in 0, we get 2. We plug in 3, we get 1. We plug in negative 3, we get 3. And we have so we have 0 and 2. We have 3 and 1. And we have negative 3 and 3. Is the line dotted or solid? It is a dotted line. So we want a dotted line on. All right, so we're back to negative 4 and 2. All right, well, I'll just make it Alright, so are we going to shade above or below? We need to shade above, we need to shade inside the solid lines, the vertical lines, and above the dotted line. Everybody okay with that one? Alright, so we're going to solve this system. The first equation, x is less than 1, is a vertical line on 1. So we draw a vertical line on 1. It is dotted. So I guess I better stop dotted. The next equation, I have y is less than 2x plus 1. I'm going to plug in 0 and get 1, 1 and get 3, negative 1 and get negative 1. Everybody okay with that? So I have 0 and 1, I have 1 and 3, and I have negative 1 and negative 1. It is also a dotted line, so I have a dotted line, something like that. The next equation we have says 2y is greater than or equal to negative x minus 3. We divide everything by 2. We get y is greater than or equal to negative 1/2 x minus 3/2. So if we plug in 0, we get negative 3/2. Plug in 1, we get negative 4/2, which is what? Negative 2. Plug in negative 1, we get negative 1. So we have 0 and 3/2, negative 3/2. Now here we have negative 1 and negative 1. We have 1 and negative 2. It is also, it is a solid line. Have a solid line here. So we have to decide where we're going to shade. We're shading to the left of the first line. We're shading below the positive slope, and we're shading above the negative slope. So we're actually shading a little triangle in between. Okay, okay, that one. The next equation is trying to determine where we're going to shade here. So we have y less than or equal to x plus 2. So we have 0 and 2, 1 and 1, 1 and 3. So we have 0 and 2, we have 1 and 1, we have negative 1 and 3. It is a solid line, so we have a solid line here. The next equation we'll do in red, we have y is less than or equal to x plus 4. So we have 0 and 4, 1 and 5, negative 1 and 3. We have 0 and 4. Are these lines parallel, perpendicular? Anybody? 1 and 5. Nobody's going to take a guess. Negative, they're perpendicular. Negative 1 and 3. Negative 1 and 3. We know they're perpendicular because the slopes are negative reciprocals. You're asked to shade below the blue and below the red. So you would shade everything through here. All right, so we're on to problem number 11. First of all, you should recognize that y is less than or equal to the absolute value of x minus 3 plus 2 is an absolute value function and should be in the shape of a V. So the first thing we want to do is take x minus 3 and make it equal to 0 to find the first point we would plug in to find the vertices of that particular function. So we get 3 and 2. So we're over at 3 and 2. That would be the vertex. We need to choose some points to the right, so 4 and 5. We need to choose some points to the left, so 1 and 2. We plug in 4, we get 3. We plug in 5, we get 4. We plug in 2, we get 3. We plug in 1, we get 4. So we have 4 and 3. We have 5 and 4. We have 2 and 3. And we have 1 and 4. It is a solid line, and it says shade below it. But let's wait and graph our other line. So we have y is less than negative 6. So we have a dotted line on negative 6, which would be right here. All right, and we're supposed to shade below y is less than negative 6. We're also supposed to shade below the other line. So let's do this. We'll shade everything below the absolute value function, and then we'll shade everything below this line. Oh, that's not coming up, is it? So what's happening is we're actually getting all of this would be the solution. Below it, y is less than, so we're shading below negative 6. So the solution, like I said, would be purple. The solution is everything below y is equal to negative 6. Is less than negative 6. So that's the solution. The next problem, numbers 12 through 14, you're asked to solve these. The easiest thing to solve for here is z. Z is equal to 4. Natalie's actually put this on the backboard. That would solve for z plus z for the second equation. We need to get 7x minus 3y equals 16. That's exactly what it takes for the two equations. The first equation and the second equation, and or not the second equation, but the second equation after we plug in the 4. And so we'll take those two equations. We have x plus y is equal to 5, and 7x minus 3y is equal to 16. So I would probably multiply the top equation by 3 to get 3x plus 3y is equal to 15. We can add these two equations together to get 10x is equal to 31. So x is equal to 31 over 10. You would then take that answer and plug it back in the first equation. So I have x plus y is equal to 5. So I have 31 tenths plus y is equal to 50 tenths. If you're going to do it in fractions, you get y is equal to 29 tenths. I wrote my answers as decimals. So I said x was equal to 3.1, that y was equal to 2.9, and z was equal to 4. So those are the solutions. That's where those three planes intersect. Okay, guys, this one's a little bit more difficult. So let's start. Do we want to eliminate x or y? Let's start with equation number 1 and equation number 2. If we multiply the top equation by negative 1, we get negative x minus 2y plus z equal negative 1. And we have x plus 3y plus 2z is equal to 7. When we add these two together, we get y plus 3z is equal to 6. Correct me if I'm wrong, y'all. Then I'm going to take 2 and 3 and eliminate the same variable, so I would have to eliminate x. So I would need to multiply this equation by negative 2. I get negative 2x minus 6y minus 4z is equal to negative 14. And I have 2x plus 6y plus z is equal to 8. I add these together. What happens? I get the x's eliminate, and I get 3z is equal to negative 6, so z is equal to 2. Is that what y'all got? So that makes it really easy, because now I don't have equations 3 and 4. I can just take z and plug it into this equation. So y plus 3 times 2 is equal to 6. So y is equal to 0. Did y'all get that? And we have solve for x. So we go back up one of the equations. Let's just do equation number 3. We have 2x plus 6 times 0 plus 2 is equal to 8. So I have 2x plus 2 is equal to 8. So 2x is 6. So x is 3. So the order triple is 3. So 2. That was all right. Which takes me to the next problem. The next problem says 2x plus y minus z is equal to 7, and 3x minus y plus 2z is equal to 15. So we'll take the first equation and the second equation and eliminate y. So I have 2x plus y minus z is equal to 7, and I have 3x minus y plus 2z is equal to 15. When I add these together, I get 5x plus z is equal to 22. Do I have that right? So then if I take equations 2 and 3, we have to eliminate the same variables, so we have to multiply this equation by negative 4. So we get negative 12x plus 4y minus 8z is equal to negative 60. And then I have x minus 4y plus z is equal to 2. When we add these two equations together, we get negative 11x minus 7z is equal to negative 58. Is that what y'all got? So now we have to equation problem 4 and equation 5. So equation 4 and 5, let's look at that again. We want to eliminate 8. Alright, so that means we have to multiply this equation by 7. So we get 35x plus 7z is equal to what? 154. And then we have negative 11x minus 7z is equal to negative 58. And you add those together, and we get 24x, is that right, is equal to 96, positive 96, so x is equal to 4. Y'all get 4 for x. Now I would probably put this back into number 4, so 5 times 4 plus z is equal to 22, so z is equal to 2. Now, let's just plug this in x and z into the third equation, so I have 4 minus 4y plus 2 is equal to 2. So I have 6 minus 4y is equal to 2. we have negative 4y is equal to negative 4, and y is equal to negative 1. Y quarter triple 4, negative 1, yes, plus 1. Thank you. So we get 4 positive 1, and what was 6? 2. All right, good. All right, everybody good to go on that? All right, so on to problem number 15, it says solve linear systems by graphing. Remember I said this is the least accurate method. You need to write your equations in y is equal to mx plus b form. Ooh. So we have 5x minus 2y is equal to negative 19. So negative 2y is equal to negative 5x minus 19. This looks like it's going to be kind of a messy problem. So we get y is equal to 5 halves x minus negative positive 19 halves. So we plug in 0, we get 19 halves. We plug in 1, we get 24 halves, or 12. And we plug in negative 1, we get 14 halves. Is that what I got on my answer sheet called? That's the first equation. So we have 0 and what is that? 9 1/2. 0 and 9 1/2. So put that point there. And then we have 1 and 12. So we'll put 12 up here. And then we have negative 1 and 7. The next equation we have says 2x plus 3y is equal to 0. So we have 3y is equal to negative 2x. So y is equal to negative 2/3 x. So we plug in 0, we get 0. We plug in 3, we get negative 2. Plug in negative 3, we have 0 and 0. We have 3 and negative 2. And we have negative 3 and 2. All right, like I said, it is the least accurate. If I had to guess, I'd probably say negative 3 and 2 is the answer. Is that the answer? Negative 3 and 2. It is consistent and independent. My graph is not good, so like I said, as long as you graph it correctly, and then if you choose something, if it doesn't intersect, that's okay. All right, on to number 16. It's going to be the same thing here. So to start with the first equation, at 2x plus 6y is equal to 6. So I have 6y is equal to negative 2x plus 6. So y is equal to negative 1/3 x plus 1. You'll notice here that these equations are the same. We have negative 1/3 x plus 1. So we know that there's an infinite number of points on the line. We only have to graph one of the lines since they are the same. So we have 0 and 1, we have 3 and 0, and we have negative 3 and 2. So we have 0 and 1, we have 3 and 0, and we have negative 3 and 2. So we know that every point on this line is a solution, so there's an infinite number of points. And you should list the line on y such that y is equal to negative 1/3 x plus 1. It is consistent and dependent. All right. I have x minus y is equal to negative 2. We're supposed to graph these as well. Isn't that correct? Number 17. All right. So I have x minus So we plug the numbers in, we get 0 and 2, 1 and 3, 1 and 1. So I have 0 and 2, I have 1 and 3, and I have negative 1 and 1. So hopefully you have a line that looks something like that. On the next equation, y is equal to negative 2x plus 5. If I plug in 0, I get 5. If I plug in 1, I get 3. If I plug in 2, I get 1. So I have 0 and 5. I have 1 and 3. And I have 2 and 1. Which is nice because we see that they intersect at 1 and 3. It is consistent and independent. Alright, so problem number 18 we're going to solve using Cramer's rule on your calculator. I don't have Cramer's rule on my calculator, so I'm just going to walk you through the steps. The first thing you want to do is go to Program. You want to choose Cramer, not Cramer's rule 3, but Cramer. Cramer solves two equations with 2 variables. Like I said, I don't have it, just want to go to Program and choose Cramer's. Then what we're going to do is we're going to put the numbers in this cabinet here. A is equal to 3, B is equal to negative 4, and C is equal to 15. And so go to Program, choose Cramer's, and enter. Then it says A, right? Put in 3. So when you get B is equal to 4, B is equal to 1, and F is equal to 1. So when you plug it all in, and you get to the final number F, you plug it in, you hit enter, what do you get for a solution? X is how much? And Y is how much? Alright, and it says consistent and independent. Or it says independent. Right? We don't care about consistent. Alright, so that's how you use Cramer's rule. But now let's look at number 19. Number 19, we're going to put this in our calculator and in a different fashion. So the first thing we're going to do is subtract 2 from x from both sides of the equation, and we're going to divide by negative 3 because it has to be in the form of y is equal to mx plus b to put it in your calculator. So we get one equation that looks like that, and then the second equation we have 2y is equal to negative x plus 7, so y is equal to negative 1/2 x plus 7 halves. Alright, so what we're going to do is we're going to go to y equals on your calculator and put these two equations in. So we'll put in the first equation, which is y is equal to 2/3 x minus 7/3 in the first equation, and in the second equation we're putting in 1/2 x plus 7/2. Is that correct? Alright. When we graph these two lines, you see that they intersect, or that they should intersect, but their intersection is way out there. So I would like to go to Window and change the window. We want to change the x, constant x value and the negative x value. So I'm going to change this to negative 5, and I'm going to change this down here to 20. Alright, so in hope that we can find where the two lines intersect, but still do is go to second trace, choose the intersection, which is 5. We're on the first curve, so we'll hit enter. It jumps to the second curve, so we're going to hit enter. And then it says, do you want to guess? Yes, so we're going to guess. And it gives us the intersecting points. Intersection 5. Are you on the first curve? Yes. Are you on the second curve? Yes. Do you want to guess where they intersect? Yes. If y'all would go ahead and put the six trailers, we'll go back to the original and put the trailers with it. So, I'm not sure what the problem is with my calculator, but the answer is 91. So we're moving on to problem number 20. Problem number 20, are you allowed to use a calculator on number 20? No? Right. So on number 20, we're going to need to do the same thing that we did before. We need to eliminate the x or y. I mean, the b or c. So I'm going to take the first two equations and eliminate b, so I get 5c plus 6 is equal to 18. Then I'm going to take the next two equations, equation 2 and 6. So on this particular problem, we multiply the top equation by -5 after we rearrange the order, and we multiply the bottom equation by 100 to get rid of the decimals. When we subtract the top equation from the bottom equation, we get 0 is equal to 0, so we know there's an infinite number of points on the line y is equal to negative decimal 65x plus decimal 5. Problem number 22. We need to decide what we're going to eliminate. Probably the easiest thing to do is to multiply the top equation by -6, get -4x plus 6y is -18. And then we have 4x plus 2y is equal to -22. We add these two equations together, we get 6y is equal to -40. So y is equal to -5. Take y and plug it back in one of the equations. Probably plug in the top equation, get 2x minus 3 times -5 is equal to 9. So I have 2x plus 15 is equal to 9. I have 2x is equal to, what is that, -6. So x is equal to -3. So I have -3 and -5. It is consistent and independent. Everybody get that for an answer for number 22? The next equation is 3 equations and 3 variables. I think the easiest way to solve this is to either eliminate x or y or z. But the question is, which two equations are you going to work with? First and third? Well, the only problem with that is z won't be eliminated in the third one. The second set of equations. Okay, well, let's start. Tell me which ones y'all want. Alright, first and the second one, we have, we'll add these two together. And we get x plus 2y is equal to 4. So then if we take the second Everybody agree with that? Alright, so we need to multiply this equation by 2. We have 4y minus 2z is equal to negative 6. And we have negative x minus 3y plus 2z is equal to 11. So we get negative x plus y is equal to 5. So we have our equation 4, we have our equation 5. So we'll just move equation 4 underneath 5 and add these together. When we do, we eliminate x. So we have 3y is equal to 9. So y is equal to 3. Probably the easiest thing to do is to plug this back into either 4 or 5. Or you actually could go and plug it back into one of the originals. So if we plug it into 4, we have x plus 2 times 3 is equal to 4. We have x plus 6 is equal to 4. So x is equal to negative 2. So we have x is equal to negative 2, y is equal to 3, and we need to find z. So to find z, I would probably plug x into the top equation. So if we plug it into the top equation, we have x plus z is equal to 7. So we'll plug negative 2 in, and we get that z is equal to 9. Did y'all get negative 2, 3, and 9 for your answer? Alright, so moving on to problem number 24. On problem number 24, you were asked to graph these. So we'll start with the first equation, or inequality. We'll plug in 0, we get 2. We plug in 1, we get 1. We plug in 2, we get 0. So we're going to have a dotted line or a solid line. Dotted. So we have 0 and 2, 1 and 1. We have 2 and 0. It is dotted. We would say above it or below it. Below it. The next equation, or inequality, was 0 and 4, 1 and 5. We'll put in negative 4 and 0. We have 0 and 4. What kind of lines are these? 1 and 5, and negative 4 and 0. What kind of lines are these? They're perpendicular because they have negative reciprocal slope. And this should be dotted as well, so I'll make it dotted. Alright. So the question is, where do we shade? We shade below the blue line and above the red line. So sectionally we shade below the blue line, above the red line. Everybody okay with that? On problem number 25. On problem number 25, you need to recognize what type of problem it is. It says the absolute value of x plus 1 is less than or equal to 3. And the absolute and x plus 3y is greater than 6. We know that the absolute value of x plus 1 is a conjunction. We have x plus 1 is less than or equal to 3. And x plus 1 is greater than or equal to negative 2. So x is less than or equal to 2. And x is greater than or equal to negative 4. So we'll graph these two lines. So we have x is less than or equal to 2. So less than or equal to 2 is a solid line on 2. And greater than or equal to negative 4. X is equal to some number is a vertical line, so that's why they're not vertical. On the next equation, we 0 and 2. We have 3 and 1. And we have negative 3 and 3. Is it dotted or solid? It is dotted. So we're going to say above the line or below the line. Above the line, it's dotted. We're going to shade less than x is less than 2, so we're shading everything in this direction, and greater than negative 4. So we're shading above the dotted line and inside the two parallel lines. Everybody okay with that? Problem number 26. We're just supposed to graph these two lines. So we start with the first line. We have 0 and negative 3. We're plugging 1 to get negative 1. We're plugging 2 to get that. So we have 0 and negative 3. We have 1 and negative 1. We have 2 and 1. It is dotted. The next question we read. We plug in 0, we get 1. We plug in 2, we get 2. We plug in negative 2, we get 0. We have 0 and 1. We have 2 and 2. We have negative 2 and 0. And it's solid. So on the first equation on the blue line, we're shading below the blue line, and we're shading below the red line. So we're shading everything below the blue line, below the red line. Are you okay with 26? On to 27. At 27, what are you asked to do? Are you asked to find the vertices of 27? So we're going to graph these three lines and then find the vertices. Those are the points that are where the lines intersect. We have y is less than negative x plus 9. For our first equation of inequality, we have 0 and 9. Let's do 5 and get 4. Let's do 9 and get 0. So we have 0 and 9. And then 0 and 9. 5 and 4. And 9 and 0. Dotted or solid? Solid. Next equation, I had negative 2y is less than or equal to negative x plus 12. I divide by a negative number. What am I going to do to the inequality? Flip it. So y is greater than 1/2 x minus this. If I plug in 0, I get negative 6. If I plug in 2, I get negative 5. If I plug in 4, I get negative 2. Is that correct? If I have 0 and negative 6, I have 2 and negative 5. I have 4 and negative 4. On top. We have 0 and negative 6. We have 2 and negative 5. We have 4 and negative 4. Dotted or solid? Solid. Okay. And the next equation is in green. Plugging 0, we get 3. Plugging 1, we get 5. Plugging 2, we get 0 and 3. We have 1 and 5. And we have 2 and 7. Alright, I really need to extend this red line. So extend that. We're shading above the red below the green line and below the blue line. So we would shade everything in the triangle. But now that's not what they asked us to do. They asked us to find the vertices. So we're looking for this point, and whatever point it is down here. So this point right here would be, what do we say? 2, 7. That point and say 9 and 0. And what is this point? -5 and what? -8. -5 and -8. Without putting it in your calculator, you really can't make an accurate decision on this because, like I said, the graphing method is the least accurate. Okay, the actual points, if you put them on your graph and found them, would be 10 and -1, 2 and 7, and -6 and -9. So those are the actual points based on our graph that we have here. We found these points. Alright, number 28, there's a problem with this, so I put this, so you don't have to put number 28. So we're on to problems numbers 29 and 30. Number 29 is a piecewise function. Remember I said they come in pieces and you need to work it as such. So first, y is equal to x plus 2 if x is less than -2. So remember we put in -2 and put in -2 to get 0. Have to keep the numbers less than -2. So -3, -4. Do -3 to get -1. -4 will get -2. So if we graph this, we have an open circle on -2 and 0. So we'll have our open circle there. Then we have -3. Oh, thank you. Wrong spot. -2 and 0 is here. I knew there was something wrong. -3 and 1, -1, so we're going here, and -4 and -2. So we have a ray that goes in this direction. And on the second part of the piecewise function, we have y is equal to 2x minus 1 if x is greater than or equal to -1. So we'll start with -1. Plug that in, we get -3. Then we'll choose 0 and 1. If we plug in 0, we get -1. If we plug in 1, we get 1. So we have -1 and -3, which is a closed circle. We have 0 and -1, and we have 1 and 1. We have a ray that goes in that direction. Then I ask you to find the domain and the range. Remember I said it gives you the domain, so you need to go back and look at the problem. The domain is x such that x is less than -2 or x is greater than or equal to -1. The range in this case is all real numbers, so we have that covered. Problem number 30. Problem number 30 is an absolute value function. Which way does it face? Does it face up or down? It faces down because there's a -2 out here. The first thing I asked you to do when you graph this was to find the vertex. To do that, we'll take 3x minus 2 and make it equal to 0. So we get 3x is equal to 2. So x is equal to 2/3. That's the first number we're going to plug in. So we'll plug in 2/3. And when we do, we get 4. So we have 2/3 and 4. So we're up here. Then we want to choose some numbers to the right and some numbers to the left. I'm going to choose 1 and 2 and choose 0 and -1. So if I plug in 1, I get 3 minus 2 is 1. times negative 2 is negative 2 plus 4 is 2. So I have 1 and 2. If I plug in 2, I get 6 minus 2 is 4, times negative 2 is negative 8, so I get negative 4. So I have 2 and negative 4. Now plug in 0, I get negative 4 and 0, so 0 and 0. And if I plug in negative 1, I get negative 5, which is positive 5 times negative 2 is negative 10, so I get negative 6. So I have negative 1 and negative 6. It is a V. It faces down and looks like that. We need to find the domain. The domain is made up of all real numbers, but what's the range? Y such that Y is what? Less than or equal to 4.